ಎಲ್ಲರಿಗೂ ನಮಸ್ಕಾರ. ಈ ವಿಡಿಯೋದಲ್ಲಿ ಫಾರ್ಮೇಷನ್ ಆಫ್ PDE ಬೈ ಎಲಿಮಿನೇಷನ್ ಅನ್ನೋ ಕಾನ್ಸೆಪ್ಟ್ ಬಗ್ಗೆ ಡಿಸ್ಕಸ್ ಮಾಡೋಕ್ಕೆ ಹೋಗ್ತಿದ್ದೀವಿ. ನಾನು ಪ್ರೀವಿಯಸ್ ವಿಡಿಯೋದಲ್ಲಿ ಹೇಳಿದಾಗೆ we are going to discuss how to form a PDE, a partial differential equation from the given function f of x comma y comma z comma a comma b. Z I can write like that, or sometimes I write like this: z a comma b comma a comma b equal to 0. See, this will be the input. If you treat the process we are going to devise as the process done by a machine, input will be the given function, a function of this form f of x comma y comma z comma a comma b equal to 0, and the output will be PDE. Here you should be careful while considering different terms. F of x comma y comma z comma a comma b means it represents a function in three variables x, y and z, and involving constants a and b. Since we are supposed to get a PDE from this, we have to treat out of these three variables one as a function of another two variables. Here we have to treat z as a function of x and y. Z as a function of x and y. Suppose you have four variables here, x, y, z, w antidre, then you can treat w as a function of x, y and z. So ಒಂದನ್ನ ಡಿಪೆಂಡೆಂಟ್ ವೇರಿಯಬಲ್ ಅಂತ ತಗೊಂಡು ಉಳಿದದನ್ನ ಇಂಡಿಪೆಂಡೆಂಟ್ ವೇರಿಯಬಲ್ಸ್ ಅಂತ ಇಟ್ಕೋಬಹುದು. So the remaining will be constants. Any number of constants you may have. There is no condition that you should have only two constants. ಅದೇ ರೀತಿಯಲ್ಲಿ there is no condition that you should have only three variables or four variables. You can have any number of variables and any number of constants. So only thing is, the given function that will be given as input should have dependent variable, independent variable and constants. Any number of quantities or parameters it may have. No restriction on that. Now we are using elimination method here. So there are two types again in this. One is eliminating arbitrary constants. And second one is eliminating arbitrary functions. Sometimes instead of this you may be given with functions in different variables. In that case we have to use eliminating arbitrary function method. In this video I am going to discuss how to form a partial differential equation by eliminating arbitrary constants. That method I am going to use, that procedure I am going to use to form partial differential equations in this section. So let us directly start with problems, so that by solving you can get the working procedure. So instead of explicit explanation for working procedure, we can learn it by solving problems. Problem 1. Problems A. The given function is z equal to x plus a into y plus b. Now this is the input function. Now I have to get output, that is I have to get a PDE from this one. Working procedure I have explained in the previous video, I think. Okay, solution given z equal to x plus a into y plus b. I have to get a partial differential equation. That means I should get a partial derivative I should get. Here it is obvious, you can directly check this. Z is a function of x and y. Z is a function in two variables, x and y. So differentiate with respect to x and y partially. So differentiating partially with respect to x, what do you get? Left hand side dou z by dou x equal to, while differentiating with respect to x partially, you have to treat y as constants. So ivaga mind alli nimage y constant anta irbeku. See, this term you have y is constant, b is constant, so this y plus b will be constant. We know that if you have ax, its derivative will be a constant into derivative of x. ಹೌದಾ? So constant ಹಾಗೆ ಇರುತ್ತೆ. So y plus b you must have as it is. Now x plus a, you have to differentiate this term. Derivative of x is 1, derivative of constant a is 0. So 1 plus 0, that is 1 into y plus b. Now dou z by dou x na p ಅಂತ ಕರ್ಕೋತೀವಿ ಅಲ್ವಾ? You can keep dou z by dou x only, no problem. Or p equal to y plus b. Next, differentiating ಇದನ್ನ ಬೇಕಾದ್ರೆ equation 1 ಅಂತ ಕರ್ಕೊಳ್ಳೋಣ. Differentiating 1 partially with respect to x ಆಯಿತು. Next, differentiating 2 1 again, differentiating 1 with respect to partially with respect to y, then I will get dou z by dou y equal to, now I am differentiating with respect to y partially, so we treat x as constant. So x plus a, all this term will be constant. So while differentiating constant term we have to write as it is. ಇಲ್ಲಿ constant ಆಗಿ ಬರ್ತದಲ್ಲ, just like that. So x plus a into y plus b, derivative of y with respect to y is 1 plus derivative of constant with respect to y is 0. So this is q equal to dou z by dou y ನ q ಅಂತ ಕರಿತೀವಿ ಅಲ್ವಾ? So notation ಅಷ್ಟೇನೆ, nothing else, x plus a. Therefore the required PDE is, the required PDE is z equal to pq. So this is the required one, z equal to pq. That is the required partial differential equation. So you can write this also like this, z equal to dou z by dou x into dou z by dou y. See, this is an equation because it involves equality sign and it involves partial derivatives, so it is a partial differential equation. So given a function, I got partial differential equation. That is the first problem. Now let us consider one more, problem 2. So the input is 2z equal to x square by a square plus y square by b square. 2z equal to x square by a square plus y square by b square. Solution: given 2z equal to x square by a square plus y square by b square. Call this as 1. Differentiating 1 with respect to x partially. So I'll get left hand side 2 into dou z by dou x. So dou z by dou x equal to, see, this term will be constant, y square by b square, because I am differentiating with respect to x means y will be constant. So y constant, so y square constant. Similarly b square constant, y square by b square will be constant. So this will be constant. On differentiation this will be 0. Now come to this, 1 by a square will be constant, you have to write as it is, derivative of x square. So 2x into 2x divided by a square. So 2 get cancelled. So that implies p equal to x by a square. P equal to x by a square. Next, differentiating 1 with respect to y partially. What we'll get? As usual, 2 into dou z by dou y equal to 2y divided by b square. So 2 get cancel. I'll get q equal to y by b square. Now thus we have 2z equal to, say I can write this 2z as x into x by a square plus y into y by b square, which is equal to x into x by a square is p plus y by b square is q. Therefore the required PDE is 2z equal to xp plus yq. Or else you can do like this. Okay. From this you can take a square equal to x by p, then you can substitute for a square here, x by p. So one term of x cancels that, and then p comes to numerator. You will get xp and yq. ಆ ಥರನೂ ಮಾಡ್ಬೋದು ಅಥವಾ ಈ ಥರ ಸಪ್ರೇಟ್ ಮಾಡಿಕೊಂಡು ಬರಿಬೋದು. ನೆಕ್ಸ್ಟ್ ಪ್ರಾಬ್ಲಮ್ ಸಿ. z square equal to 1 minus a square, sorry, 1 minus a x square minus by square. Solution: given z square equal to 1 minus ax square minus by square. Differentiating ಇದನ್ನು 1 ಅಂತ ಕರ್ಕೋಬೇಕಲ್ವಾ. Differentiating 1 with respect to x partially, I'll get 2z into dou z by dou x left hand side equal to 1. I'll get 0 after differentiation. This will get minus a into 2x, and this term will be 0. Minus by square on differentiation, that will be 0. So 2 get cancel. Z into p equal to minus ax. Z into p equal to minus ax. Okay. Next, similarly, differentiating 1 with respect to y partially, we'll get 2z into dou z by dou y equal to minus 2b into y. So 2 get cancel. Z into q equal to minus by. Now, as in the previous problem, we can write the given statement as we have from 1. So I can write this statement as z square equal to 1 minus, I have minus ax equal to zp. ಒಂದು ಕೆಲಸ ಮಾಡೋಣ, ಇದನ್ನ 1 minus ax into x ಅಂತ ಬರ್ಕೊಳ್ಳೋಣ, minus by into y, so that z square equal to 1 minus ax plus के zp ಅಂತ ಬರೀಬೋದು. 1 plus zp into x plus minus by I can write as zq into y, or z square equal to 1 plus z into px plus qy. That is the required PDE. Next, let us take one more. D. So try to solve this one. This is actually easy one. Z equal to a into log of x square plus y square plus b square. So I have to get finally the answer py minus qx equal to 0. Similarly, one more, I think it takes more steps that I will solve myself. There is a statement like problem here, A, B, C, D, E, yes. Find the PDE of the family of all spheres whose centers lie on the plane z equal to 0. Family of all spheres whose centers lies on the plane z equal to 0, having constant radius r. So this is the problem statement. Now see, in all the problems that we solved till now, the equation was given explicitly, but here it is not given explicitly. You had to write the equation of a sphere on the z plane. On the z plane means a z coordinate will be 0. So the equation of the sphere is, general equation, I will write x minus a whole square plus y minus b whole square plus z minus c whole square equal to radius square. But here it is given on z plane, then z coordinate will be 0. I should have this 0. So the equation becomes what? X minus a whole square plus y minus b whole square plus z square equal to r square. This I had to take as equation 1. Now we need to find the PDE of this. Differentiating 1 with respect to x partially. Differentiating 1 with respect to x partially. So I'll get 2 times of x minus a into derivative of x minus a is 1 plus this y minus b whole square term will be 0 plus z square, that will be 2z into dou z by dou x equal to r is anyway constant, so differentiating that I will get 0. Dividing the equation throughout by 2, this 2 vanishes. So I will get x minus a plus z into p equal to 0, or can write zp equal to minus of x minus a, better, or you can write a minus x, no problem in that. So similarly, if we differentiate equation 1 with respect to y partially, same argument repeats there. So I will get 2 times of y minus b plus 2z into dou z by dou y equal to 0. Next, that implies y minus b plus, okay, I'll write this here, y minus b plus 2z into q equal to, sorry, 2 vanish alwa, z into q equal to 0, or y minus b equal to minus zq. So you can write this as this, also we can write as minus zp equal to s minus zp equal to x minus a. Now substituting for x minus a and y minus b in equation 1. In place of x minus a I can write minus zp. In place of y minus b I can write minus zq. So what do we get? Substituting for x minus a and y minus b in 1, we get minus zp whole square plus minus zq whole square plus z square equal to r square. So that is z square p square plus z square q square plus z square equal to r square, or z square ಹೊರಗಡೆ ತಗೋಬೋದಾ, p square plus q square plus 1 equal to r square. So this is the required PDE. This is the required PDE. So that's over BCDE. Okay, anyway, try to solve this one. X square by a square plus y square by b square plus z square by c square equal to 1. You have to get finally z into dou z by dou y, that is zq equal to xz into dou square z by dou x square plus dou z by dou x whole square. So try to solve this on your own. We'll consider one more. See, one more important point I have to note down here. We have these notations: p equal to dou z by dou x, q equal to dou z by dou y, r will be stands for dou square z by dou x square, s stands for dou square z by dou x dou y, or dou y dou x. You can interchange these two. And t stands for dou square z by dou y square. This you have to note down, because here I got this one, dou square z by dou x square. So I got this one, so I am telling this. So these are the notations that we fix to write PDE out of the given function. Next, one more problem. Problem EF ಆಯ್ತಲ್ವಾ, G Z equal to y square plus 2 times of f of 1 by x plus log y. We need to find the PDE out of this one. Solution given z equal to y square plus 2f of 1 by x plus log y. Call this as equation 1. Differentiating with respect to x partially, I'll get dou z by dou x equal to 2y. So we treat y as constant, so obviously y square will be constant. Differentiating that, I'll get 0 plus 2 times of derivative of f, I think bracket not necessary, 2 into, you have some function, so derivative of f is f dash of 1 by x plus log y into derivative of inner function log y will be constant, so differentiating that I will get 0. Derivative of 1 by x I will get minus 1 by x square. So I got, so I will get t equal to minus 2 f dash by x square. I can simply write f dash means f dash of 1 by x plus log y. Differentiating 1 with respect to y partially, differentiating 1 with respect to y partially, I'll get dou z by dou y equal to 2y plus 2 into derivative of f, that is f dash of 1 by x plus log y, into derivative of inner function. Derivative of 1 by x will be 0 because we are differentiating partially with respect to y. So x is constant, 1 by x constant, differentiating that I will get 0. Derivative of log y, you get 1 by y. So from this I will get q equal to 2y plus 2 by y into f dash. Okay, we got this one. Now from this I can write px square equal to minus 2f dash. So call this as equation 2. From this I can write q minus 2y equal to, I want to eliminate this f dash, so that's what I am trying. Q minus 2y equal to 2 by y into f dash. Better we do one thing, q minus 2y into y equal to 2f dash. Call this as 3. Now equation 2 divided by 3. What it implies, let's see. Left hand side px square divided by q minus 2y into y equal to minus here 2f dash divided by 2f dash. So these two get cancelled, you get minus 1 here. So cross multiplying that, px square minus of q minus 2y into y equal to 0, or px square minus qy somewhere we got wrong here. Yes, px square equal to minus q times of 1 minus 2y. Yes, this step we have not written properly. So cross multiplying px square equal to minus of q minus 2y into y yes, this is the proper step. So that implies px square equal to minus qy plus 2y square. So I'll get px square plus qy equal to 2y square. This is the required PDE. So finally we solve one more problem. The last problem on this concept. Z equal to y into f of x. I think problem H it is z equal to y into f of x plus x into phi of y. This almost comes under eliminating arbitrary functions. Yes, in previous problem also we eliminated f. Yes, here we eliminated f. So this comes under elimination of arbitrary functions. Here also we have f and phi, we have to eliminate these two. So again we have moved to eliminating arbitrary functions part. But here we have separate type. That problem we discuss in the next video. So we are eliminating arbitrary functions here. Be clear about it. So okay, z equal to y into f of x plus x into phi of y. Solution given z equal to y into f of x plus x into phi of y. We have to eliminate f and phi. Now as usual, differentiating 1 with respect to x partially. Differentiating 1 with respect to x partially. What do we get? Dou z by dou x equal to y into f dash of x plus phi of y. Y into f dash of x plus phi of y. Call this as equation 2 time being. Differentiating with respect to y partially. Differentiating 1 with respect to y partially. So I'll get dou z by dou y equal to f of x plus x into phi dash of y. See, from equation 2 and 3, eliminating phi and f is difficult. So let us go for higher derivative. Differentiating 2 with respect to x partially. So I am differentiating z with respect, differentiating z with respect to x partially twice. So I'll get dou square z by dou x square equal to, I am differentiating with respect to x, right? So y into f double dash of x plus, this is phi of y, that vanishes. Similarly, differentiating equation 2, I have to get mixed derivative also with respect to y partially. So from this you can write r equal to y f double dash. If you want, you can call that as equation 4. Differentiating equation 2 with respect to y partially, dou square z by dou x dou y equal to dou square z by dou x dou y equal to f dash of x plus phi dash of y. Equation 5. Next, differentiating with respect to which equation? Differentiating equation 3 with respect to y partially. This is equation 3, dou z by dou y. I am differentiating that with respect to y partially again. So I'll get dou square z by dou y square equal to f of x. If I differentiate with respect to y, that will be 0 plus x into phi double dash of y. This is equation 6. Okay, I got 6 equations. Now from equation 2 we have f dash of x equal to, see, from equation 2 f dash of x equal to, this equation I am going to use explicitly. From this f dash of x I get, from this I get phi dash of y, then I will substitute here. What we get? Dou z by dou x minus phi of y divided by y. So from this f dash of x equal to dou z by dou x minus phi of y divided by y. So I'll get f dash of x equal to dou z by dou x, that is p na, p minus phi of y divided by y. P minus phi of y, see, this is p actually. So p minus phi of y, this pi of y divided by y. Similarly from equation 3, phi dash of y equal to q minus f of x divided by x. Equation 3 implies phi dash of y equal to q minus f of x divided by x. Substituting this in equation 5, I'll get, say, dou square z by dou x dou y, ಇದು r ಆಯ್ತಲ್ಲ, ಇದು s equal to p minus qy divided by y plus q minus that is f dash of x, phi dash of y. Okay, I got this one, phi of y, sorry, p minus phi of y s divided by y plus q minus f of x divided by x. Multiplying xy on both sides, we'll get sxy equal to p minus phi of y plus q minus f of x. So sxy equal to p plus q minus of f of x plus phi of y. Okay, yes, I got wrong again. This is x into, this will be y into. Okay, this I'll write once again. Here y, here x. So multiplying both sides by xy. So I'll get sxy equal to, here y get cancel, x into p minus phi of y plus y into x get cancel, you remain with y into q minus f of x. So sxy equal to xp minus x into phi of y plus yq minus y into f of x. So that implies sxy equal to xp plus yq minus of y f of x plus x phi of y. But y f of x minus x phi of y is y f of x plus x phi of y is z. So this I can replace by z. So sxy equal to xp plus yq minus z. This is the required PDE. So with this and one more exercise problem on eliminating arbitrary functions concept, find the PDE corresponding to the equation z equal to f of x plus ct plus g of x minus ct. So I have to get the answer dou square z by dou t square equal to c square into dou square z by dou x square. So this is the solution of that problem. So with this we are ending part of formation of PDE concept. So there is one more small method that we shall discuss in our next video. Thank you.